Dear students, today we'll see multiple choice questions on semiconductor electronics, which can be useful in competitive exams like JEE, NEET, CET. So let's start with the first question of this part. Question number 31. Boolean expression a bar plus b bar the whole bar can also be written as what? So if you see the expression, it is a bar plus b bar the whole bar. Now this expression can be simplified by using the De Morgan's theorem law, where it says that complementary of the sum can be converted into complementary of individual products. Okay, so here we can write this expression as a bar plus b bar the whole bar. Now this you can convert into complement of individual and product of them. So this can be written as a bar bar into b bar bar. And if there are two bars, then the value of that is the variable itself. So this you can write it as a into b. So here if you see this option 4 will be the right answer. That means Boolean expression a bar plus b bar the whole bar can also be written as a into b. So here you can see option 4 is the right answer. Then we'll go to the next question. Question number 32. Choose the correct option out of the 4 options given below. Now here if you see the first option is a plus 0. Now if you take a as 0, then 0 plus 0 is equal to 0. This expression stands correct. But now if you take a as 1, 1 plus 0 is equal to 1. So in this case, this expression stands wrong. So this is not the correct option. If you take the second expression, so second expression is a plus 1 is equal to 0. If a is 0, then it is 0 plus 1 is equal to 1. If a is 1, it is 1 plus 1 is equal to 1. So in this case also, the second expression is not correct. If you take the third expression, if a is 0 plus a bar, if a is 0, then a bar will be 1, then this will be 1. And if you take a as 1, then a bar will be 0, this will be 1. So this expression stands correct. So option 3 is the right answer. In the same way, we'll also check the option 4. Now in this case, if you see if a is 0, 0 plus 0, that is a plus a is equal to 0. If a is 1, 1 plus 1 is equal to 1. So here in this case, again, this option also stands wrong. So option 3 is the right answer here. That is a plus a bar is equal to 1. So here you can see a plus a bar is equal to 1 is the correct option. And then we'll go to the next question. Question number 33. In LED and photodiode, the PN junction is respectively what? That means how we are going to bias or how we are going to apply the voltage to LED and photodiode. So what kind of biasing it requires, whether it requires forward biasing or reverse biasing. So if you see the theory of LED, LED will glow when the voltage applied to it is in forward bias. So if the PN junction is forward bias in case of LED, it is going to glow, it is going to conduct. Therefore, LED should be forward biased. And in case of photodiode, so it is going to convert your light energy into electrical energy. So in that case, the photodiode is respectively biased in reverse. So it should be reverse biased. So the depletion layer, that is the width of the depletion, can be used for the photo, or that is light conversion into electricity. So here LED should be forward biased and photodiode should be reverse biased. So here if you see the 4 options, in this the second option says LED should be forward biased. So here you can see it is the second option which is giving the first, that is the forward bias. This is forward bias for LED and reverse bias for photodiode. So this option is the correct option for this question. So here you can see in LED and photodiode, the PN junction is forward biased in LED and reverse biased for photodiode. Then we'll go to the next question. Question number 34. The following truth table corresponds to the logic gate. Now here a truth table is shown. Now in this truth table, we see A and B as inputs and Y is output. So here you can see A and B as inputs and Y is output. So if the inputs are 0, 0, the output is 0. If the input is 0, 1, the output is 1. If the input is 1, 0, the output is 1. And if the input is 1, 1, the output is 1. So here we see that if the input, any one of the input is high, or if both the inputs are high, the output is high. And the output is low only when both the inputs are low. Now this description goes with OR gate. So this description is for OR gate. So you can see the symbol of OR gate. It will be somewhat like this. This will be a symbol. So here these are the two inputs A and B. This is Y, and this truth table corresponds to this OR gate. So here out of these four options, option 2, that is OR gate, is the right answer. So here you can see second option, that is OR gate, is the right answer. Then we'll go to the next question, question number 35. Identify the operation performed by the given circuit. So if you see this circuit, in this circuit we have two inputs. The first input A is given to a NOR gate whose both the inputs are shorted. So it is acting as a NOT gate. So output of this will be A bar. Similarly, if you see the second input, that is also given to a NOR gate, and the output of that NOR gate will be like a NOT gate because both its inputs are shorted. So here the output will be B bar. So if A bar and B bar are the two inputs given to another NOR gate, so here the output will be Y is equal to A bar plus B bar, the whole bar. Now this is the output what we get at the third NOR gate, that is Y is equal to. Now this output we can simplify again as we have seen in the first question according to the De Morgan's theorem. So here we can write this as A bar bar into B bar bar. So this is nothing but A into B. So Y is equal to A into B. Now A into B is the expression followed by AND gate. This is a expression for AND gate, and therefore out of these four options, that is NOT, AND, OR and NAND will be the correct answer. So the operation performed by the above circuit is the AND operation, and that is the option second. So here you can see the second option is the correct answer. Then we'll go to the next question, question number 36. The forbidden energy gap in conductors, semiconductors and insulators are Eg1, Eg2 and Eg3. That means the forbidden energy gap for conductor is Eg1, for semiconductor is Eg2, and for insulator is Eg3. Then which among the following relation is going to be true? So here, if you remember the energy band diagram for a conductor, insulator and semiconductor. So here you can see for a conductor, if you see both the bands in the energy band diagram, that is the valence band. This is the valence band, and this is the conduction band. This will be the conduction band. So both the bands will overlap each other. So there is no gap. The gap is the valence band and conduction band are going to overlap. If you see semiconductor, there will be a small energy gap between valence band and conduction band. So this is valence band and this is a conduction band, and there will be a small energy band gap of 1.1 electron volt. And if you see the energy band diagram for insulator, there will be a large gap between valence band, this is valence band, and this is a conduction band. So here you can have a band gap of 15 electron volt. So here this says that the energy gap, that is forbidden energy gap, for insulator is more, for semiconductor is less as 1.1 electron volt, and in a conductor it is not there, it is going to overlap. So forbidden energy band gap in conductor is the least. Okay, that means it is not existing over there, and therefore out of these expressions, if you see Eg1, if it is the forbidden energy gap for conductor, and Eg2 is for semiconductor, and Eg3 for insulator, then out of these options, if you see option 2 will be the right answer. So option 2 says that EG1 is less than EG2 and EG2 is less than EG3. So option 2 is the right answer here. So here you can see option 2, that is EG1 less than EG2 and EG2 is less than EG3 is the correct answer. Then we'll go to the next question. What is the current in the circuit shown? Now if you see this circuit, there is a diode here. There is a diode here. This is anode of the diode. This is cathode of the diode. There is a resistance R of 300 ohms. So the voltage applied at the anode is minus 4 volt and voltage applied at the cathode is minus 1 volt. So these are the voltages applied. Now here if you see, minus 4 volt is less than minus 1 volt. That means the voltage applied at anode is less than the voltage applied at cathode. Therefore, this diode is going to be reverse biased. So this is going to be reverse biased. And when it is reverse biased, there is no current flowing through the diode. So there is no current flowing through the diode, and therefore the current in the circuit is 0 ampere. So here out of these 4 options, the first option is the right answer, that is 0 ampere. So here you can see 0 ampere is the correct answer. Then we'll go to the next question. Question number 38. So here it says that the PN junction shown in the following circuit diagram is as follows. So here we can see a PN junction. So this is a PN junction diode and the applied voltage here is 1 volt. So here you can see this is 1 volt applied voltage at the anode, and at the cathode you have the voltage as 2 volt. So and here you are having a resistance of 100 ohms. So the PN junction shown in the following circuit diagram is what? So the options are reverse biased, forward biased, not biased, or data insufficient. So if you see the applied voltage here, the anode is been applied with a voltage of 1 volt and the cathode is applied with a voltage of 2 volt. That means the voltage at the anode is less than the voltage at the cathode. And this definition says that if the voltage at the anode is less than the voltage of the cathode, then the PN junction or the diode is reverse biased. It is reverse biased. So here the first option is the correct answer, that in this case the diode is reverse biased. So here you can see option 1 is the right answer. Then we'll go to the next question. Question number 39. The following configuration of gate is equivalent to what? So here configuration is shown. Now here we are having 2 inputs A and B. Now these 2 inputs are applied to a OR gate here. So after the OR gate, the output what you get for the OR gate will be A plus B. And here you can see the same 2 inputs are applied for NAND gate here. Now the output for NAND gate here will be A plus, it will be A into B the whole bar. Okay. Now this 2 are again applied to the next AND gate. So A plus B is one of the input for this AND gate, and A into B whole bar will be the input for this AND gate. So here the AND gate has to give the output as A plus B into A into B whole bar. Okay, now this is the output of the AND gate what we have. Now if you take this, now this can be written as A plus B, and A into B whole bar according to De Morgan's theorem can be written as A bar plus B bar. Now if you multiply them and according to the Boolean algebra, we can have this as A into A bar plus A into B bar plus A bar B plus B into B bar. Okay. Now here if you see A into A bar is nothing but 0 and B into B bar is nothing but 0, then what remains here is A into B bar plus A bar into B, and this expression is the expression which is followed by the XOR gate. So this is the expression for XOR gate, and here out of these 4 options, NAND, XOR, NOT and OR, XOR will be the right answer. That is the above configuration is of XOR gate. It is equivalent to XOR gate. So here you can see option 2 is the right answer, that is XOR gate. Then we'll do next question. A PN junction diode D shown in the figure can act as a rectifier when an alternating current source V is connected in the circuit. The current in the resistor can be shown by what? So here you can see there is a applied voltage V, and this applied voltage is an alternating quantity. This is an alternating quantity. Okay, now we know that this diode is going to act as a rectifier. A rectifier is a circuit which will convert alternating quantity into direct quantity, that is a pulsating DC. So here, whenever the input is positive half cycle, the diode is going to conduct and we are going to get output. So if you see the output current here, whenever the input is positive half cycle, we are going to get a positive half cycle. Whenever the input is negative half cycle, the diode will be reverse biased, so we don't get any output over here. Then again, the input is positive half cycle, we get a positive half cycle here. Again, when the input is negative half cycle, we don't get anything here. So this process goes on. The output current is going to flow, the diode is going to conduct whenever the input is positive half cycle, and the current through the resistor also will show a positive half cycle only when the input is positive half cycle. So out of these options, if you see, the first option is showing both positive and negative half cycles. The second option is showing positive half cycles for all types of input, whether the input is positive or negative. Whereas the third is showing positive half cycle when the input is positive, and when the input is negative, there is no output here. Again, when the input is positive, the output is positive. And the fourth is a direct current, a pure DC. So out of these four options, option 3 is the right answer, because we are going to get a positive half cycle when the input is positive only, and when the input is negative, there is no output. So it is option 3 which is the correct answer here. So here you can see that option 3 is the right answer. Okay. Thank you, students.